Howdy everyone, it is Chef Evans again, and we are here to talk about chapter 5, it's actually chapter 4, even though it says chapter 5, which is the flow of food, or an introduction. And as we move forward, please make sure that you are pausing and jotting down notes as I'm going over them, because remember, these are things that you can use for the quizzes going forward, and they will help you the most as opposed to just reading over it or listening to it once. Y'all know yourselves. I know I would need notes, especially those of y'all at home. You want to make sure that you are taking notes because you do not have the benefit of our in-person lessons. Okay. All right. Again, I'm not going to sit here and read these objectives to you. We're just going to talk about the things that happen to food along the flow of food in an operation. All right, so the flow of food is defined as the path that food takes through your operation. And it starts with purchasing and then goes through receiving, storing, preparation, cooking, holding, cooling, reheating, and service. So all these different things play a part in what happens to your food throughout the operation. Our main focus throughout this chapter is to prevent cross-contamination and to prevent time temperature abuse. Now, we're talking about the flow of food. So let's say a frozen food might be safe when it leaves a processor's plant. However, on the way to the supplier's warehouse, the food might thaw. And then once in the operation, the food might not be stored correctly, or it might not be cooked to the correct internal temperature. These mistakes can add up and cause a foodborne illness, which is what we're concerned with it today. So cross-contamination can happen at almost any point in the flow of food. When you know how and where it can happen, it is fairly easy to prevent. The most basic way is to keep raw and ready-to-eat food away from each other. Each type of food should have separate equipment. For example, use one set of cutting boards, utensils, and containers for raw poultry, and use another for raw meat. Use a third for produce, and so on. Colored cutting boards and utensils can help keep equipment separate. Different colors can tell food handlers which equipment to use with each food item. You might use yellow for raw chicken, red for raw meat, and green for produce. We don't have that luxury here at the Reef. All of our cutting boards are white, but we do have separate areas that we do prep raw and ready to eat food. We are going to always make sure that we clean and sanitize all work surfaces, equipment, and utensils after each task. Excuse me. When you cut up raw chicken, for example, you cannot get by with just rinsing the equipment. Pathogens such as salmonella can contaminate food throughout the cross-contamination. And to prevent this, we must wash, rinse, and sanitize everything. So for example, here this person is working with raw meat. So we're going to have to make sure wash, rinse, sanitize everything before working with anything else. As I said before, we do not have separate cutting boards for our product, but we do take good care to keep everything all separate and have all of our different stations separated throughout the kitchen in order to make the flow of food work best for our purposes. Okay, so if we do need to use the same table to prep different types of food, then we're going to try and do it at separate times. So for instance, those of y'all who have had our class in the morning know that that's when we try and do all of our raw meat preparation, poultry, and then our ready-to-eat food doesn't come into place until during service. And we're going to try when possible to prep ready-to-eat food before raw food, and that is we'll have to show you examples of that in order for it to make sense. But we are going to have to clean and sanitize all of our work surfaces and utensils between each type of food. Also, by prepping ready-to-eat food before raw food, you can reduce the chance for cross-contamination. We could also buy food that doesn't require much prep or handling. For example, you could buy pre-cooked chicken breasts or chopped lettuce. We could, but that's not how we do things here at the Reef. Y'all are here to get an education, so it wouldn't do a whole lot of good for us to have a whole bunch of pre-shredded iceberg or pre-grilled chicken to use on our products. Now, if I had my own cafe, for instance, and I had unskilled workers working for me and I wasn't there, I would probably do this. I would order pre-cut lettuce or pre-shredded cheese or pre-cooked meats in order to prevent cross-contamination or time temperature abuse. Okay, so now we're going to move on to temperature control. Time temperature abuse is another major hazard in the flow of food. Remember that TCS food has been time temperature abused anytime it remains between 41 to 135, which is what? That's the danger zone, Chefy. You like my cursive? So anytime food is within this range, it has been time temperature abused. It can also be abused when it is cooked to the wrong internal temperature, held at the wrong internal temperature, or cooked or reheated incorrectly. That is called temperature abuse. Now, we learned before that we call this the danger zone because pathogens grow best in this temperature range. And what is the super danger zone that we talked about? Yes, 70 to 125. That is our super danger zone. And that is because pathogens grow much faster between those temperatures than they do any other. So the longer food stays in the temperature danger zone, the more time pathogens have to grow. To keep food safe, you must reduce the time it spends in this temperature range. If food is held for 4 hours or more in this zone, you have to throw it out. All right? We'll talk more about that a little bit later. All right, so moving on to time temperature control. So in order to avoid time temperature abuse, we're going to make sure everyone has their own thermometer. So once we go into the kitchen, we are going to require that you have thermometers, and we do periodic checks for those. We're going to use timers in prep areas to check how long food is in the danger zone. And our class is kind of made up for this because we only have 15 minutes per period. So our food is our setup works perfectly for this because we are automatically temping and checking our food because it's only out for a certain amount of time to begin with. Make sure that you have different kinds of thermometers available for different procedures, and we'll talk about that a little bit more. Record temperatures, minimize the time that food spends in the danger zone, and take corrective actions if the time standards are not met. And like I said, we have our own procedures for doing that. For example, if we have a soup that has been off of the heat and I temp it and it's at 130, that's within the danger zone. So what am I going to do? I'm going to take corrective action to make sure that it is fixed for service. All right. So we have many different types of thermometers available. The ones we use here at the Reef are called bimetallic stemmed thermometers, and there's a couple of different important points. So this is the tip, and this little thing here is the dimple. So when you are temping food, You will insert the thermometer up to the dimple point to get an accurate temperature. This entire area here is the sensing area that it actually temps the food, and you will read the temperature up here on the indicator head. Up here we also have our calibration nut, and we'll talk about what part this has to play in our temperatures in a little bit. But this is the important part about our bimetallic stem thermometer. We do sell them here, and it does come with a protective sleeve that is multi-purpose as well. Now we do have to make sure that our thermometers are calibrated to within 2 degrees. So plus or minus 2 degrees Fahrenheit, it has to be calibrated to, and we'll talk about how we do that. Thermocouples and thermistors are going to be measuring temperature through a metal probe. So this is fantastic for measuring really thin food because you only have to get the tip of the probe in there. Whereas with our bimetallic stem, you actually have to insert it properly to get a correct reading. They're good for checking the temperature of thick or thin food. They come with different types of probes. They have an immersion probe, a surface probe, a penetration probe, and an air probe, where we can actually check the air temperature of something, say, like your flat top or a saute pan. If you want to actually check just the temperature of it, you would use one of those. Then we have our infrared or laser thermometers. Those are used just to check, just to check the surface temperature of a product. You would use these when you're worried about cross-contamination because you don't actually touch your product with this thermometer. You would get as close as you possibly can to the product that you want to temp, and it will actually give you the external temp. It does not record the internal temperature of food. So you want to make sure that you're not using it for that. I'm not sure what is on the outside of this food, but I would have removed that as well before taking the temp. Then we have the maximum registering thermometer, which will tell you the maximum temperature that that thermometer has reached. It is used a lot for dish machines because it will tell you the highest temperature of the final rinse, which is very important. Then we also have the time temperature indicators, which are used a lot of times by manufacturers. They will attach it to the product or the box itself so that you as the business owner can tell if the product has been time or temperature abused before delivery. Because if it has, this will change color, and it is irreversible, meaning once it changes color, that's it. You know that it's been time or temperature abused, and you have to throw it out. I would not accept this kind of product if they tried to deliver it to me. So that is a TTI, or a time temperature indicator. Now we're going to talk about how to calibrate our thermometers. They can lose their accuracy when they're bumped or dropped, or when they go through a severe temperature change. So when this happens, we need to calibrate it or give an adjustment to make sure it has a correct reading. We also have different types of thermometers that cannot be calibrated, that just need to be replaced or be sent back to the manufacturer. There are two different ways to calibrate a thermometer. One is to adjust it based on the temperature at which water freezes, and this is called the ice point method. Or we have it at which point water boils, which is called the boiling point method. And we'll talk about both. The boiling point method, which is a little more dangerous, is just that. We're going to bring water to a boil, and then you can see we're going to use the sleeve that the thermometer is in to actually hold it over the water, and we will adjust the calibration nut underneath so that it reads 212 degrees, which is, of course, the temperature of boiling water. So you can see here we don't enjoy this method just because look at this person's wearing some heat resistant gloves, and we don't have those here at the reef. We do have towels and whatnot, but this is the unsafer of the two methods. The next one is the ice point method, which is our preferred method just because it is so much safer. So you're going to fill a container with ice and cold water, and then again you're going to use your sleeve to hold the thermometer in place and submerge it in the ice water. And then we will adjust the thermometer so that it reads 32 degrees, which is also the temperature for what? Freezing water. Okay, so once we do either method, you're going to hold it there for at least 30 seconds so that it does calibrate before removing it. And then you will wash, rinse, and sanitize it just like any other time you use your thermometer. When you are washing them, again, wash, rinse, sanitize, and air dry before and after using them. And then you're going to want to calibrate after you do any one of these things. After they've been bumped or dropped, been exposed to extreme temperature changes, before deliveries arrive, or before each shift. You always want to make sure you have plenty of clean and sanitized thermometers on hand, and that you make sure that they are calibrated to the manufacturer's direction each time. So when you're using them, you want to make sure that they are accurate. So when you calibrate your thermometers, it must be within plus or 2 minus degrees. If you're checking air temperature, however, they have to be calibrated to plus or minus 3 degrees. Now, we don't use glass thermometers here at the reef, but if you were to use one, you would have to make sure that it is encased in a shatterproof casing, just so that we don't have any physical contamination of any sort, because that would be bad. You're also going to want to make sure that you insert the thermometer into the thickest part of the food, because most foods have thin or thicker areas, and if that happens and you submerge your thermometer into the thick end, or excuse me, the thin end, it's not going to be the same temperature as the thick end. So you always want to make sure that you're taking the larger side's temperature first, and that you can check it in multiple places. You want to make sure that your reading stays without moving up or down for at least 15 seconds. If there are any questions about